Hello. So Twisted is an event-driven networking engine written in Python. And why should you care? Is because it's super easy to implement applications on top of the existing implemented protocol. It's asynchronous, and it's implemented in a way that that's not thread-like API. So you don't need to deal with some synchronization stuff. It helps with C10K problem, which is about handling 10,000s of connections with the server. And the asynchronous approach is effective for applications that are I/O bound. And it's quite elegantly designed. It started at about year 2000, when Glyph were working on a game called Twisted Reality. And it was originally in Java, and he found it difficult to implement the code with threads correctly. So he looked for an alternative, and he found it in Python, which at the time implemented select module, which allowed him to implement the asynchronous code. And eventually it evolved into the networking engine. Its big advantage is the existing protocol implementations, where if you want to use them, it's just a matter of implementing the prepared interfaces. It can use foreign event loops from GUI frameworks, so you can use Twisted as networking support in these applications. These are the main parts that Twisted is composed of. And firstly, it's the reactor, which implements the event loop. That is probably at the lowest level of dealing with the input and output. Then there are protocols, which implement the actual network protocols. There is a difference when you work with Twisted, whether you either receive events or you generate events. So when you receive them, it usually works in a way where you derive an existing class and implement the event method. While when you are generating events, you use that protocol object externally, and you will get a thread object, and then you work with that. Then there are transports and factories, and these work basically as plumbing between the reactor and the protocols. So when you are actually implementing some kind of server that receives events, you create a transport object with a factory that you make listening on some TCP socket via the reactor. When the client connects, the factory creates the protocol object, transports deliver data into the protocol handles them, and when the connection is terminated, the protocol object is destroyed as well. The transports and protocols should be separated. So you can basically take a protocol object and run it over different transports. Whether you want to run it with HTTP or overall TCP. This is the basic diagram of how the event loop works. So you have the reactor loop, which checks some file descriptors, or possibly some other things. And when it gets data, it will call back to your code. And the flow is of the execution is exactly as on the diagram. So if you this asynchronous I/O is basically a cooperative multitasking. So if your code happens to block, the whole server is blocked. It might be better understandable with a very simplified example of naive versions of the reactor and the transport. So here we have a class of naive reactor which you can run, and you can see that it is basically busy looping and checking or iterating over the transport it has attached, and it calls read on them. Then the transport is having a file descriptor on itself, and it's set into non-blocking mode, which means that when you try read it, it will either return data or it will throw an error with error code 11, which says that there are no data available. No, wait. That's not right. In this case, the error 11 would mean that the file descriptor was lost, in which case the protocol is notified of that event, that the file descriptor went away. Otherwise, it delivers the data into the protocol via the data received method. And any protocol that implements anything starts always with the data received method. There should be covered case where the data are not available, in which case nothing happens. And the read on naive transport should immediately return. So the naive reactor continues running and checking the status of the descriptors. Any questions so far? I don't know Java, so I don't know about this. Do you know whether it uses threads?
I think it's also non-blocking, because now I have blocked thread for the waiting. It also does something like that there is a listener is waiting for the message, and where the message is getting, then it proceeds.
Okay. It may be very similar.
It's
but,
pretty similar, so
but I can't say.
Yeah.
Here's an example of an actual code that's in Twisted, and that's an implementation for IRC client. So it starts with deriving a protocol that is named basic line receiver, and that is a protocol that builds upon the basic protocol, which can receive data via the method data received. And it basically buffers the data until it can read the whole line, and once the whole line is read, it will fire off a method called line received, and the IRC client processes this event further. So at the end, from the user point of view, you will end up with API that looks like on this slide. So if you want to implement a client, you need to just derive the IRC client protocol and implement, for example, the user joined method, which, as you can see in the doc string, is called when the user joins the channel. So that's basically the example implementation of your actual bot, which simply responds to a newly joined user with hello and his nickname. Then we need a factory that will create this protocol. So it's inheriting Twisted Internet Protocol reconnecting client factory, which, as the name suggests, is capable of reconnecting once the connection is lost. So you don't need to take care of that. Then we have Reactor imported from the Twisted Internet somewhere, and you tell it to connect to a TCP socket and give it the bot factory, and then you fire off the reactor. So the reactor starts running only after you call the method run, and the transport object is created by the connect TCP method. If you want to test these protocols, it's really simple because you can test it on just the protocol. So you can create a simple test case where you just create the protocol and simulate what happens inside Twisted once it connects the transport. So one of the base methods of protocols is also make connection, which gives the protocol to transport. And when you write data back to the socket or somewhere, you call methods on the self-transport write. So in the test case, we can just stick string IO in there, which simulates a writer, and later you can get the written value with the get value method. So then you just push into the protocol the actual line from IRC server, and then test that it responds with the appropriate other IRC line. Questions? In case you want to generate events, you need to use the deferred object. And well, first you need to get a protocol or some kind of proxy that can send the requests you need. So in this case, I'm using Twisted Web Client agent that calls a GET request on some kind of URL and with empty headers. And the point of deferred is that it is returned immediately without blocking, and it's an object that it's an object on which you can attach a callback or an airbag that will get fired once the result actually arrives back. So In this case, we are adding callback, which is a lambda function. It gets one parameter, which is the response object, and the response object is separated into reading headers and the actual HTTP body. So here we have to call the response deliver body. Yeah, that R should be actually response on the line 7. So you deliver it into your protocol object, and that can implement anything you want, depending on the data you will receive in the HTTP body response. But in case you don't receive a successful response, you will get fired an airbag, which is added on the line 9, and it just prints that something went wrong and exits. And at the end, there is added call to reactor stop, because this is written as a one-time script. So it should send only one request, then process the result, and quit the program. So in case we didn't call the reactor stop, the program would hang just doing nothing. And you can use this in your, as we saw in the example with the IRC, if a user joins, you can do the exact same thing there. Let's say you want to check some HTTP API, so you will call the agent with the request, get the thread back, and process it. This is the diagram of the callback chains, because this shows that you have a data source which returns the result or the failure into the thread object, and then you get fired of the callbacks or airbags. And in the callbacks or the airbags, you can chain more callbacks one after another. So any of them can fail again. So as you designed the callback chain, you can get from callbacks into airbags or back. In case you get an airbag and you know how to fix it, you can get back into the callback chain. But it's not completely without problems. As most libraries don't provide asynchronous API, so when you call into such library, it will block, and what may happen is that unless you get the response really fast enough, the whole server will block. So that is the case with SQL Alchemy, for example. I've seen some people handle it with a method called defer to thread. So that's kind of a workaround to use blocking libraries. And recently appeared Project Alchemia, which I think leverages some new API of SQL Alchemy, where it's possible to inject some kind of strategy object which can turn the blocking API into returning the threads, and it's usable with Twisted. When I was researching this, I saw a VaniaMart project which somehow used Django ORM if you are inclined this way, but I don't really know how. Then there is DB API library inside the Twisted itself, but it provides no fancy stuff, so it's just raw SQL. And there is Twistar, which is Active Record for Twisted, but I don't like Active Record and I've never used it. So that's here for completeness. Twisted provides its own runner for unit testing. I don't really know why, but it's nicer than NoStats, for example. So you need to write the tests correctly. That is not touching the reactor as much as possible, because then it may happen to you that test failures will either hang the test suite forever or manifest in later test cases, which is really difficult to track down. As a platform, as I said, as it can't use blocking libraries easily, it's kind of its own ecosystem. So it might not be easy to use the libraries you are used to. There is relatively speed, so when new standards get adopted, it might take some time until the protocols are updated to reflect them. So that concludes my talk. Any questions? Oh, actually, there is a nice manual, or rather tutorials on these URLs. So that's good to check out. And any questions?
Is there Python 3 support yet?
Yes, it's partial. I think the Twisted core is working with Python 3 already for some time, but it's composed from a lot of modules and components. So I don't think all of them has been converted yet. Any?
Have you looked into the new Cubes project yet, or not new, but the proposed new infrastructure to replace protocols and factories?
How did you call it?
Cubes.
Cubes?
Cubes.
No.
Like the internet is composed of cubes.
Oh,
so,
right. I remember reading a headline, and at the time I thought it's some kind of joke.
Well, it's been undergoing for like 3 years now. Several attempts to completely redesign the.
Right. I am aware that in Python 3 there is a proposal that adds async library or something like that.
Async.io, which
right.
is practically completely identical, not in naming but in function to Twisted Core, but of course doesn't have the protocols. It's just,
right. It's
just the event loop.
Right.
And has its own future object instead of the current.
Right. But it's the Python 3 async.io is heavily inspired by Twisted design.
Yeah.
But I haven't looked into the tubes.
I'd say that unfortunately because it takes the protocol and transport objects which are not really composable to as layers, and cubes is meant to make it easy so you can have, for example, TLS cubes that encourages then tokenizer cubes that parses net strings, and another cube that does the another layer of processing, and you can compose it and also switch the plumbing as you go. So you can, for example, after a start TLS command, plug in the TLS queue to start encryption and so on.
Cool. So, any other questions? So, thanks for listening.